right, it is cooking. So who wants to go first? You go first. All right. So Van's thing is up. All right, so we're gonna do today a security hash algorithm and Unity EM engine. So I do research a lot about SAR, not a lot, but enough to do the presentation. The SAR is the security hash algorithm, published on National Institute of Standards and Technology, 1993. Was revived by 1995 as known as SAR1. But first, when we talk about the SAR1, I'm talking about the SAR0. The regional applied original version is a 160 bit hash function, but due to it's not like the new version and it's crackable. So basically, they are updated into the SAR1 known as MD5. MD5, it means the Macys digest. It still uses 160 bit function, but reasonably early MD5. They are failed cryptographic discovery on the SAR1 and no longer used for cryptographic after 2010. The national security is NSA is updated into the SAR2, similar to the SAR0 and 1, but they are using the 256 and 512 bit. There are different in the word side though. 250 they use 32 bit, and 512 they use 64 bit word sign. There are also the truncated version on each standard. They know at like SAR 224 or something. It's still also designed by NSA. Talking about the digested Macys is the design to protect integrity of the piece of data. Media change will be part of the Macys. Whenever you want to do something, you have to change the Macys, and they will detect it. Alongside cryptographic, they authorize hash value that can warning copyright of the owner. They can use on the window. But I don't know, they can crack the window though. Digested Macys is encrypted with the private key. Sorry, my bad writing there. Create a digital signature will be, your owner own the key, and you can come back to fix this later. And I'm talking about the Bitcoin. The Bitcoin is digital money, cryptocurrency. Created by Satoshi Nakamoto, published in 2009. The hope of the Bitcoin, though, they want to replace the currency that we have current right now, but they have a problem. The problem is double spending. They want to get basically, you want to go out. You don't need the money on the pocket. You want to have your phone and you can pay everything, like Samsung Pay, but you use Bitcoin to pay, and they have you can do anything without fee or the small amount fee, and the Bitcoin pretty good at that one, but they have a problem double spending. Like what is double spending? The double spending is basically they have one like hash function in the pocket. They know one Bitcoin that you have, and then you send to John 1 Bitcoin, and you send to that you 1 Bitcoin, another 1 Bitcoin. You get the products, but they didn't know that. They cannot, valuable about the double spending. But after that, they fixed the problem pretty fast on the double spending. Is a buyer they have Bitcoin and the seller A and B. It cannot the double spending because they will put into the block and two different blocks. And one is valuable a lot by by miner. They call miner. Broadcasts a lot. That means the available block, and the second block will be rechecked. That is why they fix the double spending on the Bitcoin. Give me 1 second. So on the double spending, Bitcoin use a prevent the problem by confirmation mechanics and maintenance a universe larger car block. So basically, you have currency on the money on your pocket, like $2. You go to the store, you buy the food, you give them $10. They give the item is worth $10, and they put it on the straw, and then you lost $10. So that is currency on money that you have. The double spending is you give them $10 and give another guy $10, but it's not, because in your pocket only have $10. So the Bitcoin use that to verify the double spending on the Bitcoin on the currency. So they're not allowed to use the double spending. One block is available. That means the second block is done, rechecked. And I'm doing research about the Unity game engine. The Unity game engine, they have a lot of engine, but two powerful tool is online right now. It's a Unity and Unreal Engine. I don't do a lot about Unreal Engine. Unity game engines I use a lot. A Unity game engine can be used on 2D game, 3D game. It's not about the game only. You can build all kind of stuff like physical stuff. You can build, the building, training stuff, hospital, everything physical, reality. So can be open or test, modifying the game by Unity. I think Unreal Engine is the same. Unity using C#, JavaScript, pretty much easy because they are higher level language. Make your own game. You want to create your game. If you have animation, you can import it in. There are also lots of effects on the Unity, light effect, a lot that can help you to build your game. It supports the virtual reality that Oculus and Vive. So basically, you're wearing helmet and you can go different world outside. But in the future, though, I think they will have the reality touch that you can wear the armor. You can be in the battlefield whenever they shoot at you, and whether they shoot at you. Like you have the helmet and they're gonna shoot in your head. The head is gonna be shaking. You can't see anything, or you got shot on the body. You got vibration on your body. So that's just this cool technique on the feature. Because right now lots of people play game, and people do a lot of stuff on the game or create animation. So basically the Unity tool is going to be the powerful tool, and I prefer C# or JavaScript. I don't know, but the C# is pretty good for Unity tool. That'd be all for my research. Took me lots of stuff. Took me lots of time.
So what are you going to be looking at doing for next week? So you had, encryption technology. You talked about cryptocurrency stuff, which uses some of that technology, and then the Unity thing is kind of very different than those, right?
Yeah.
So what are you looking at as your topic for?
I'm looking for the research on next week for combine both them for virtual reality with the cryptocurrency. Basically, that I want to go back to process that you can be working on your exercise and you earn a Bitcoin or something. So basically, I will do that research. Um, I want to follow my research for a long times ago that you can earn the coin and stuff by physical workout. And how does that work?
And how will you get information on that? Or are you going to pull some information and then present some of your own stuff?
Yeah, so I'm gonna go to find a paper about related to the cryptocurrency online and the Unity stuff, and I will combine them together um, to see how they work. Otherwise, I will do the Unity only, um, creating the game or so how it work on the Unity.
Okay. All right. So next week we're going to be looking at cryptocurrency in the Unity game engine related to in VR, people applying their own physical activity to proof of work.
Yeah.
Okay. All right. Fair enough. Next. I got here real early. Keep on trucking.
All right. Okay, so I chose a lot of my articles I found were actually kind of related to 3D printing or like scanning. I started researching and I was like, I don't know where to go with this because so many things you can tie into creativity. So I kind of found 3D printing and I kind of went with that. So a lot of them are related to that. So the first one I was really interested in, it was a dual extruder 3D printer. And what it was doing, they modified a home 3D printer to print PLA filament plus a electronic conducting, I want to say fluid, essentially on the PLA, so they could make circuits essentially. The goal was that if they could do this on a printer for really low cost, so someone at home could be printing a circuit essentially. The code they used was actually like C++, and the way they did was they used an Arduino Uno. They uploaded the G code onto there and had that work with both the extruders. Both of them were on the same axis motors, but they were able to implement it over. So like if they needed to print the PLA and then they needed to print the other the fluid essentially on it, they would just shift it over on the x-axis because that's what the extruder heads were on. The difficulties they actually found with this was the viscosity of the fluid they were using. It was, I think it was called bare metal or something like that. I think that's what it was called. And essentially it would be really watery because it's a water-based fluid. So it wasn't very accurate. So they were thinking maybe we can make this a thicker substance and so it would be more conductive or more easier to print out, but the conductivity, I think that's a word, that actually goes down. So there's some pros and cons to doing both of that. So overall, it concluded with it's a basic start to this type of printing where they can simultaneously print the PLA and the electronic substance on that. The second one I found was reversible shape change structures by grayscale pattern. So this is called, what's really important in technology and what's like used by a lot of the STEM careers that they're looking for in aerospace technology, things like that is, it's called reversible structures. And essentially what they can do is they have something they make, and then by applying something to it, whether it be a voltage or putting a chemical on it or something, it actually changes shape. And then when it dries, it'll go back to that shape, or if they apply a different opposite voltage, it'll go back to that shape. Well, they're kind of trying to do that technology here with a 3D printer. So what they do is they would 3D print the structure, and there's a big long name for all the materials in it, this resin that they used. They'd 3D print this shape, and then it would be let's say a square, but they'd print one side with one material and the other side with another material, and then once it dried, that the grayscale side would actually dry and shrink, so it would cause it to warp a little bit or to morph into a different shape. And then when they would take that shape and they would put it into an acetone and water solution, it would actually morph back into the original shape. So they essentially made a reversible structure. And the resin they used to, if you're interested in all this, if you know what these are, polydiacrylic, how do you say that? You're in pharmacy. Oligomers. So that's the stuff they used. But the way they printed it was with UV light. So it's like, I think there's a 3D printer in the back there that uses lasers to print. So it's kind of like that. They used UV light to expose the elements, and that would actually harden the substance on there. So this is really cool way that new technology that they're coming out with. They want to be able to 3D print small parts or even big parts that they could reverse in shape. And I think this is really basic, really early on start to this. But they also found out that if you, depending upon the intensity of the UV light, they can actually determine how much the shape morphs, which is kind of cool. So if they had just a hardly like a 10% UV light when they're curing it, like it wouldn't actually morph that much. They can determine like angles and things like that, or how much it will morph. That's really cool. All right. Third one I found was like in pharmacy field. So transdermal drug delivery. So these patches or these microneedles, what I was finding, or what the article is saying, is how it's expensive to produce these microneedles, or these patches are inaccurate at delivering medicine. I might be wrong too. Don't correct me. The patches are like inaccurate delivering the correct amount of medicine per person, because everybody has different dermal skin levels or dermal thicknesses, and so they can be pretty good, but they weren't like as accurate as they'd like. So they were finding like these microneedles, like different methods with that, whether it be these needles have a cap on them, and then when they put the patch on, those caps stay in your skin, or they these are hollow points, hollow needles, and then so like the medicine would go in after they stick it in, or like had to throw that in. Or the needles actually are the part that dissolves, so when they put the patch on, those stay in your skin. And what they were trying to do here is they actually used inkjet technology and 3D printing technology. They're trying to be able to print these really tiny needles. The technology behind the whole printing part, they were struggling with a little bit more, but that was some new technology that I was struggling, like trying to understand how they were getting it so small. But essentially the inkjet technology was really cool. They had these, say, patches of like microneedles, and what they do is they do it's called drop on demand, where they take like essentially a printer head, and it would go across and drop specifically right onto that needle, just the right amount of in this case they use like antifungal and antimicrobial substance on that to make sure that it was clean, but then they could put like the drugs on that as well. So in conclusion, they were saying that this is also new, and this might be a viable or cheaper option for production. Rather than having to ship out to an external company for these patches or things like that, they can do it specifically to that patient within their own clinic there, should this get down to a smaller scale. As of now, it's still expensive, but the goal is to make it cheaper. Okay, application of multimodal 2D and 3D imaging. They took 2 Roman silver denarii, where they that's what they used for guinea pigs for this. They essentially were utilizing all these different scanning and photo techniques that they could, just to see like if they can classify that coin easier, or like how much data can they get from that. So like I have a whole list of things here, like, you know, photography focus stacking. So essentially they'd have different focal points, and they take a picture and take a different focal point, take a picture, and then they put all those together and they can get a really clear picture and know exactly how thick it is. The dome photography, they use a special camera where they can take a picture of the top, and it gets with a special lens, and it actually gets to see all the way around. I guess XRF, so that's X-ray fluoride spectroscopy. I don't know, I can't pronounce it, but it doesn't matter. Then
Van can help you.
yeah, Van, help me out. Spectrometry. Okay. Anyway, they used all these different techniques, and the goal was they were getting to see what is a viable way to classify all these coins, like things that they get like in museums or things like that. So they were trying to see, all these techniques are very expensive, so they want to be like, if we're getting all this massive amounts of data, how can we make this be automated? So we put a coin on a table or put an artifact on a table. How will it do all these? What scanning techniques can they do to that to make it like be automatically scanned and classified into a system? Because that was the whole point. They want to be able to do these automated, and that's where like the computers come in really key, because they have to process all this huge amounts of data coming in from all these different sources, and it has to be understood too. And then they can also, from that, they can determine like what year it's coming from, like how old it is, things like that. So better classifying the coins and things like that. Oh, this was cool. This was kind of a shorter article, but I kind of thought it was cool. This guy, I think it was out of Florida, he's looking at 3D printing pillboxes. So the commercial pillboxes that doctors issue, or you can get from like the Walgreens or things like that, they're just standard. But his idea was like, would we have more effectiveness to 3D print custom pillboxes for that patient based upon what pills they need to be taking? What they did was they generated 9 different 3D printed pillboxes based upon that person's need or that patient's need, and they were seeing if the overall ratings of that, and they were getting better ratings, and their I think what they refer to it as medication adherence, the overall level was higher. So people were actually taking their medicine or their medication better or more often correctly than they.
What was unique about the pill bottles?
So say like one day they have to take 1, or another day they have to take 3, another day they have to take 4, or maybe this patient is like colorblind or something like that, so they can make the filament different colors or things like that. They can put different factors in it. They can shape it differently. I don't know, just different things that would be customized to that patient. And
something made sense.
Something made sense to them. So something they found that made sense, and they could actually, and they talked about this very briefly. Like they could go do psychological tests, to say like, okay, this person responds better to circles and better than squares, random things like that. But essentially, they can say, all right, we can 3D print a custom pillbox for that person in our clinic today for that person, and we can adjust that as needed because it's relatively cheap to do that.
And that's not actually horribly off base. I'm working on a project with the pharmacy school and the nursing department on this thing called MedSync.
Yeah.
Where we're looking at increasing adherence for pills, and we went and visited a kind of a mom and pop pharmacy and kind of talked to them about what things they do. And something that was interesting there that, I haven't used like a small box pharmacy since I was a kid. I used to, I go to Walgreens, or you go to Target, or I think my current, actually now we use Express Scripts, that's what Concordia uses. But, regardless, there's no personal service there. So, in my mind, I couldn't figure out, like, well, what does that mean for like a pharmacy? And what was really cool is this pharmacist up in Sheboygan, I think it's more geared towards older folks who might be on, 7, 8, 9, 10 pills.
Right, exactly.
They pack them they have like a printing thing that pre-packs them for their morning pills, afternoon pills, stuff like that, where they just take out a pocket, open it, take all those pills.
Right.
And it's like help them with adherence a whole bunch. And a lot of that's not even because people don't want to take the pills, it's because these older folks, they can't tell one pill from another.
Right.
So I think that there's like a whole industry
for
that type of thing. So I think that's kind of an interest. I mean, I never considered like doing some sort of customized pill bottle.
Yeah, I don't know. It was just kind of interesting. I was like,
it seems like there might be some truth.
There's something truth to it, yeah. And I was like, they actually have numbers to back up. Granted, they only did 9, and then they did it with I don't know how many patients they had, but like the fact that they could customize it, I think that was cool, and their numbers were up. So yeah.
I mean, I probably wouldn't take all my pills. My wife didn't put them into these. I have this giant container with these dividers in it.
Yeah.
So, like Monday morning, that's what you take all those and just dump it. If she ever wanted to, poison me, she just put a different pill in. I take whatever's in the bucket. Whatever's in that bucket, that's what I swallow. Otherwise, my adherence would be terrible.
Yeah.
I wouldn't follow it at all.
Yeah, it's cool. Yeah. So that was the 5 articles I had. I think I might actually do my research next week on the circuitry, the electronic circuits on with simultaneous like 3D printing. So I think it'd be really cool if eventually we got to the point where you could 3D print like a PCB board with like electronic circuits on it at home. I think that's cool. So I want to see where that kind of the technology's at and so do more research.
I think that sounds. That's kind of the one I was hoping you were going to pick. Because that's a little bit kind of in your wheelhouse, anyways. But also. In technology, everything we're looking at is going to making things smaller, smaller. And we're in the current world right now with 3D printing where you can't get that small because these are spilling over, and so where does that meet? I'm interested in learning about that.
That'll be cool.
I mean, 3D print that can print the organs.
The what?
They can print the organs.
They can print organs.
Yeah. Okay. Yeah. Like tissues. Yeah, it's cool. I like that technology. Is really cool. I could found a bunch of articles.
Yeah, later the black market in China got cheaper on the
cheaper Chinese 3D printed organs. Is that the use lower end filament?
Yeah, low end filament. You can get a kidney for $100.
It just fails half the time.
Cool, but I'm gonna tell like no warranty.
I have a Chinese 3D printer that I built. It was just a kit. It works amazing.
By the way, our remote guy is not going to be here today. He had a death in the family, so he'll give his both presentations next week. He emailed me. Just FYI, he won't be showing up.
Okay. So my first topic is artificial intelligence in healthcare. So how innovatively we can use artificial intelligence in the healthcare industry. So like there are limitations what a human doctor can do, like what kind of analysis he can do on the patients, like because he has only knowledge which he knows, because he cannot analyze large amount of data, and he can't do many other stuff which modern machine learning algorithms can do. For example, we can use machine learning techniques, a camera, whatever we can collect data from different gadgets, like we have this Fitbits and many other healthcare gadgets. We can collect vast amount of data from different healthcare gadgets, and a machine learning algorithm can predict the future. So depending upon the symptoms of the like blood pressure and different symptoms, it can predict how long a person going to live, or what kind of future disease he's going to get contracted. But there are many implications of this, because most of the times when this artificial intelligence algorithms predict something, we don't know what process they have taken. I mean, what kind of process they have done in order to come to that conclusion, because most of the time it just gives the end result. Even if it gives the step, whatever the steps it's gone, mostly it is related to some neural networks, something which we will end user cannot understand. So there are some implications as well for this. For example, if some algorithm has predicted incorrect result, then who will be responsible for that legal liability? I think about it. And my second topic is quantum cryptography. We use traditional cryptographic algorithms like what are the RSA, both public as well as private cryptographic algorithms. The problem with them is they work fine. The problem with this, all of them rely on some computational complexity. These computational complexity are obviously very difficult to crack. It requires a lot of computation. But with modern computers and distributed computing, we can crack these algorithms. Theoretically, we can crack. So there is no algorithm, classical cryptographic algorithm, which is foolproof. So for that, we have with the help of quantum physics laws, we can have something called quantum cryptography. So quantum cryptography, at least theoretically, it will give us unhackable a system of cryptography, because mm, the one of the problem in this classical cryptography is key distribution. When we distribute key distribution, there is a chance someone can get access to that key distribution. But quantum with the help of quantum physics, we can there is one nature of the quantum physics is, if we measure the property of a quantum state, it will change. So mm, if some attacker tries to eavesdrop the key, tries to get access to the key, the sender and receiver, what are the communicating properties, sender and receiver will know that there is some tampering is going on, someone is going to access the copy of the state. So they through that uh, communicating parties can know that someone is trying to access the key, so they can discard that key and generate a new key. My next topic is mobile edge computing. uh, so so right now, cloud computing, as we all know, cloud computing uh, is a current technology where we store all the information, all the processing, every information is done at the central server, and our mobile devices or whatever will access after processing, we'll get the result and access it, like Siri, assistant, whatever, all the technologies work in that way. But uh, there is a but problem with this is, in future when we have a lot of IoT devices and lot of applications like augmented reality, lot of resource intensive applications, uh, uh, there is some latency, because the information should be we should get information from the cloud, so there is always going to be some latency. So this mobile edge computing, what it does is, sorry, this technology, what this technology is, we uh, sto- mobile edge server is within the RAN network, within the radio access network. So we don't so that uh, it clears the bottleneck to the internet. My next topic is visual and analytics using IBM Watson. So so in this research paper, what researchers have done, they researched on the cancer, about the cancer, like uh, what are the trends and patterns of the cancer disease across the world. So with the help of IBM Watson Analytics platform, they were able to because they have this access to huge amount of data across the world, like different kinds of cancer, what kind of people usually get that cancer. So this is a huge data. If they can get access to all data, if they can analyze some patterns and trends, it will be helpful for in the future research. So for that, uh, IBM Watson Analytics can give different graphs, charts and graphs, and we can analyze the data. Yeah, my next topic is facial recognition applications. Like uh, now, now, facial recognition technology can be used in many places, like retail, healthcare, retail, and so many places. Like uh, for example, even Amazon is introduced Amazon Go. So it in Amazon Go stores nothing, but there is no need for the cashier. They can use the camera and the other sensor technology to track of the shoppers. And also face recognition technology can also use for the security, like fraud detection, whatever. And also we can get rid of passwords like Apple Face ID. So these are some of the applications.
So what are you planning on for next week?
Quantum computer.
Okay. Anything specific you want to do with that?
Uh,
What excites you about that topic?
yeah, because it's a theoretically it's unhackable. All other algorithms are some way, at least theoretically, they should be hackable if provided we have infinite computer, like large amount of computation. But this is unhackable.
Okay, so are you going to be approaching it from a explanation of why it's
Yeah,
unhackable?
yeah,
I mean, because it's only unhackable so far as we understand the technology right now. If you were to, be given, if somebody gave you a checkbox, true or false, is this technology truly unhackable? I would probably check false. It's probably got similar weaknesses to anything else. We just don't understand it at this point. So, that would be my gut feeling. So, are you exploring why it might be unhackable, or are you?
yeah,
Exploring...
because the quantum laws itself, quantum physics laws, whatever the reading I've done, it is because when you try to read a quantum state, it will disturb the whatever the because there is some uncertainty principle, probability, and uncertainty principle. If you try to measure one property of a quantum property, it will affect the other one. So it, at least right now, I mean, no one is able to disprove that fact. That one.
Fair enough. Okay. Fair enough.
I got a question about the Amazon Go. Is that
Yeah.
That's where they go in and they can just you kind of
you can grab it.
Yeah. Yeah. So there's like the facial recognition.
Facial recognition and sensors. It's a combination of.
When you walk in and then it's
yeah.
And then it's like, all right, I know who you are.
Yeah.
So like I know how much money you have.
No. When you walk in, you use the app, Amazon Go app.
Okay.
So you scan it and you go to the shop.
Okay, so it doesn't know you're in. Okay.
It knows that you're in, but what happens? Why it requires facial recognition is, say you grab something, grab some object, but later you've decided that you don't want to purchase. You put it back. It should know that who has put it back, whether you have put it back or it should know, right? Because if you grab it, it will think that you are purchasing it. But if you put it back, it should know who has put it back. So it keep tracks of you till you end.
That's cool.
You're not gonna know who the hell are you want to steal it or not.
I'm gonna wear your face. I'm gonna go in there.
Well, what keeps somebody from taking something off the shelf? I mean, I'm assuming that, at least early on, it could work backwards. They just credit your current bill. So let's say that I take a can of soup off the shelf, then you take a can of soup off the shelf. I hand you my can of soup, you put it back onto the shelf. Now you have a free can of soup.
Yeah, that's called double spending.
I'm not sure when they're actually billing me when I leave the place. If I walk out, I've taken a bunch of stuff off the shelf and handed them off to somebody else. So I've never actually put anything back on the shelf, but I also didn't leave the premises with anything. So just because I took something off the shelf doesn't mean I bought it. I could put it down in all sorts of different places. So I don't know. It'd be interesting. I mean, I think there's only a couple of those that are actually open for testing, right? Those, I wonder how they're going to end up doing.
Well, they're gonna. I believe later they're gonna tell the employees that whenever you take the stuff, you don't want it, you have to put it back on the plate that
the exact place you took it from.
Not exactly that you put it from. You just put on the place that they create on the front door. So whenever you took it and you don't like it, you just put it back on that plate.
How about as soon as you take it, you bought it?
Yeah, as soon as you take the can.
That's yours.
The transaction.
That's done.
Done.
You just bought that.
Yeah, you just bought it.
Yeah.
And then when you put it back, you return it.
Yeah,
no, you can't return it.
Can't return it.
No, he's not that trip, because then that's called browsing. That's not how Amazon became a $1 trillion company.
That's true.
It's not showing down anymore though because of that happened yesterday.
Well, so what? They're a little bit under $1 trillion.
In their hair. They made it. They're sure.
It does kind of be true. I am.
I mean, even Apple didn't fall that hard, even though yesterday everyone's stocks went down, they were still $1 trillion,
Yeah,
when Amazon fell.
Yeah,
Well,
they
how
will
does-
reach 2 trillion.
I actually don't even get how Amazon makes so much money on their sales and stuff. Because I mean, I very much view Amazon as a try before you buy type of thing. I mean, it's completely common for me to buy something on Amazon that I think I might want. And then I can use it for up to 30 days. And if I decide it's good, I'll keep it. If I'm not happy with it for any reason, you send it back. And all you have to do is select one of the options that indicates, item not as described, or, I mean, that one's easy. You just say it's not as awesome as you made it sound like. So and that way they pay for the shipping to send it back. It doesn't cost you anything to send it back.
No, right now I think
They charge you
Yeah.
now. They charge you now if you return things.
No, not if you select a reason for sending it back that falls into one of the free categories, like item was described on the website incorrectly, or item defective, those types of things.
But
They
it
don't
also,
charge you for it.
it also depends too. Sometimes they charge, they'll charge you sometimes for that too.
because
Sometimes even the software
they already charging you when you purchase the stuff. Like you can buy the headphone in the Best Buy only $2. Go to Amazon.
But they say they make
$30.
most of their money off their servers.
The cloud computing.
They said 75% of the revenues
It's coming from cloud computing
Yeah.
stuff.
Yeah.
I see.
That's crazy.
So I'm sure they're making money off me from product purchases because I keep most of what I buy. And a lot of the stuff that I'm buying, I'm keeping are more expensive things like a $2,000 computer and stuff like that. But man, I mean, you get like a $15 or $20 gadget, like a golf gadget or something like that. It doesn't live up to it. Half the time they don't even want it back. You put it in there and says, yeah, it's not what I expected. It's like, yeah, just keep it.
But I would say
For me,
they're
how many of those 100 people are going to return it? That's it.
Yeah.
So like 1 out of those 100, they're still making a profit on that, right?
Yeah, I think they have economies of
But
scale.
the thing is, for me,
They have the
you gotta
kind
have
of
a lot-
scale they can afford.
For me, it's a
Because they have-
you're gonna have a lot of
I don't
contact with different companies like Macy's stuff. The Macy's should be put up online on Amazon. Create a different site for Amazon, like okay, Macy's Amazon. You buy Amazon, they ship it to you through Amazon. Seriously, like seller. Right now, Macy's the store is closing a lot.
Yeah.
Right now, they.
Well, Amazon has this new thing now. If I want to return something, I don't even have to box it up and take it to the UPS store anymore.
Yeah.
I can walk it into Kohl's just as is.
It Kohl's?
Yeah.
No way.
Yeah, it's a specific relationship they have with Kohl's. I can take something that I got from Amazon. I can just walk it into Kohl's as is. They'll box it up and they'll send it back for me.
Free?
Free.
Free.
And I also heard they're gonna start delivering and stuff.
Buying
using
so much stuff
UPS.
today.
They've already been doing
They're
that.
gonna start doing that.
Yeah. There's already quite a bit of handoff between UPS and the post office. And then they even have their own Amazon. You see these little black Amazon trucks that
Yeah.
are driving around. And I think a
They
lot of
just-
that's coming from the not Sheboygan.
I just read it recently.
Somerset.
They just bought 20,000 more of those trucks and stuff, and they're trying to expand and stuff.
Interesting.
You're gonna go online shopping later than PC store, Boston store,
Haven't we already kind of moved towards that? I mean, especially in our area here, you can get a lot of stuff same day.
Yeah.
Especially if you're in the Milwaukee area. Unless you need something right now, I mean, why put pants on? I mean, you could just order it and it's at your doorstep the next day or even the same day.
Like you don't have to spend your gas to go drive somewhere to buy it too.
I've bought shoes through there. I mean, it's great.
I mean, they're gonna use virtual reality for us to try on the clothes too. Think about it, and that's how they make more money. So you don't have to waste that shipping cost and stuff.
Yeah, well, we'll see. We'll see. I mean, that's actually an interesting area. I mean, that would be something interesting to look into is whether it's VR or some sort of there's an app called like mTailor or something like that where you take a video of you from the side and all this stuff, and they tailor clothes to you based on, I guess, the dimensions they figure out from that video. I thought about actually trying it. I mean, I don't wear tailored clothes. I usually have to get my clothes from a Technonic store.
Yeah.
Well, if you're buying, I'll take it.
Well, but I mean, I honestly thought about it from a research
Yeah.
perspective. Why not
That's so
try it?
cool.
I mean, let's see what they would come up for. I mean, so I'm 6'5", 370 pounds.
What would they do?
Could they come up with a tailor fit shirt that would fit me?
Well, they're gonna 3D print them.
3D print my
And
shirt.
I'll have a circuit in it too.
But I mean, actually, maybe I should do that. Maybe I'll do that
You should.
this
That's
weekend.
cool.
Because it's like $50 for a shirt. What's the worst that happens? I get a shirt that's like a really nice custom fit like dress shirt.
Yeah.
The only reason I don't wear dress shirts is they don't fit me right.
Yeah.
So, yeah, interesting. All right, well, good. I would probably say for next week, even if it's just a couple like individual slides, to just talk about your paper. That way, there's a kind of visual, like even just this thing right here, where I mean, it doesn't really matter what this thing says.
Yeah.
Just the fact that I'm thinking about, okay, he's talking about 3D printing. Okay, that's fine. Yeah.
Wait, so we can talk more than one topic, and then after that, figure out which one we want and use it for the paper, or how does this work?
So yeah, well, so today you're like presenting your 5 papers that you read, right? So you read 5 papers. They could be on the same topic from 5 different angles. They could be on completely different topics, like several of these have been. Then you're going to presumably pick one of those, possibly that was a good pop.
Thank you. Sorry.
No, I'm impressed. I have lower back problems, and I'm always impressed when somebody can get like a really solid pop that way. That's an A for the day, but you know. Presumably, you're going to pick a topic from one of your 5 papers. More than likely. But you might say, okay, well, here's the 5 papers I happen to find. I read all these. They bored the hell out of me. I happen to see this thing over here that seemed interesting, has nothing to do with what I read here. I'm going to pick this topic. That's okay, too.
So, but then there has to be research already for that topic?
It doesn't have to be. I mean, that would probably be to your benefit. But if there's something, I mean, actually, it would be kind of neat if you read 5 papers for today and you said, I wonder what if they did this. And you look around and you say, nobody else has done that. Spend a week looking into the starting point of that and explaining. I mean, maybe you find out, this is why they haven't done this, because this won't work. Maybe you figure that out, but that's okay. I mean, it doesn't have to be something that somebody's already worked on. It's a topic that is related to this thing that you want to learn more of.
Oh, okay.
So this week, you're exploring what other people have done stuff on. Next week, for next week, you're going to be looking into your own topic, whether it's something other people have already done stuff on that you want to learn more about that specific thing, or if you want to go down the rabbit hole and take a completely different twist and say, okay, well, here's something nobody's done yet. Maybe there's a good reason for that, or maybe it's you're a genius and you came up with something nobody else thought of. Could be. So you should have us all sign an NDA at the beginning of class when you come in. But yeah, I mean, it's real flexible as long as you're learning something from the process. But this week should be about what's currently out there. Next week should be either let me learn more about something that's currently out there, or here's.
But like they're currently working on it, but it's not like they didn't publish anything for it yet. Does that still count too? Or?
If you're in doubt, I can look at the paper or something like that, or you can tell me what the idea is, and I'll tell you whether that sounds reasonable. But in general, I mean, if it's in the realm of advancing the area of computer science, it's probably fine.
I use like Scholarly or the library on CW, my CW, there's library, and then there's that little search bar, and that'll give you all like articles, journal articles.
It's to your benefit if there's already stuff out there that you can learn from rather than having to reinvent the wheel. Your life will be easier to be able to look at other people's work on a specific topic.
Yeah, because like what I did for this week was the black box for the algorithms and artificial intelligence. I mean, I try to find things on like World 5 research, but it's kind of hard because they're still doing research on it, and then it's just while they're doing research, these are what like the researchers are thinking about we should do, but they didn't really elaborate on it because there's reasons. Because like the field, like it's complex to understand, like they were saying, and then or like companies don't want to make like black box transparent because of like,
I get you.
intellectual property.
But that's okay. So you've effectively taken the temperature of the current field in it, where it's kind of budding from lots of different angles, but none of them are all that far.
Yeah.
That's okay. So then maybe for this next week, you take it a step further, or you make some more conclusions, or you make some predictions of where it's going next. Yeah.
Okay.
Cool. All right, next.
I guess I'll go
Fight to the death. Oh.
You're,
Oh yeah, you already started, so you're just.
Do I have to go up there?
Yeah,
Okay.
that way the recording will hear you.
All right.
Well, the good news is we'll get to be done early. You'll take a nap.
That's called going to
Go to bed. No, it's only 7 o'clock. If you haven't started on next week's stuff yet, you're not gonna finish.
I'm talking. I wanted to do research on the black box of algorithms and AI, and the problem that a lot of researchers are finding is that 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 AIs are getting complex to understand, especially when we're programming it with codes, because it's to the point like we're adding too many lines of codes and it's hard to follow what's going on, and sometimes the machine will act for some reason, like they'll act unpredictably, and we don't understand why, and has led to like many problems that we see today happening, like events like the Google imaging, where people when someone typed in a black person, a gorilla would popped up, or like Uber, when the car did detect a pedestrian, um, it it detected it, but it didn't avoid it and still killed the pedestrians. And there's problems like that. We don't people in the field don't understand what's going on, and they want to take a closer look at trying to slow down the advancement of AI and try to spend more time in understanding this problem. But a lot of people don't want to do this because they don't see it as a problem because it works. Um, it works, but um, it, and but they want to find like different ways. The researchers want to like uh, try to understand it better by like trying to make the um, algorithms more transparent by um, transparent by they want to make it more transparent and try to understand, like they want to break down the algorithms so that they could understand it by step by like programming it and programming it and they want to have like a way that we can like check or like audit like the program, so like it doesn't like do things that I mentioned that like cause harm to people or do things unethical or have like human bias characteristics and stuff like that. Uh, and these are the things that people are still trying to figure out and work on. And a lot of people are afraid that like we don't like focus more on this, that like there'll be more problems for us later on because we're becoming so dependent on the technology because we use it in our everyday lives, that like worse things could happen than we've seen already. And some people are afraid that it might like cause like our species to like cease to exist and stuff like that. And I want to try to look into that and see like if there's I mean, I did read an article like they did say that there's like they had something for like when checking credit scores or something, they would do like some, like they would have like they would explain to the person that's trying to get someone's credit report like why the algorithms were gave you like this information, like how did they come by to get you this result like that. I want to look into that and see that if there's ways we can like implement it at a bigger scale and making like the artificial intelligent work and stuff like that. And yeah, that's basically it.
I mean, so what's kind of interesting is with any sort of machine learning type stuff, are what you're training the AIs on is only as good as the data you're feeding it. And then we have to consider how unbiased is the data you're feeding. And I was reading a paper, must have been 3 or 4 months ago, a similar type topic, but it was kind of talking about the implications of a AI being trained on normal everyday data. Would it be racist? So would, I think it was something along the lines of, some of the like white cops killing black teenagers, things like that, where, a lot of white people point to that and say, oh, well, they're just doing their job, and black people say they're being racist, and these are all emotionally driven, right?
Yeah.
When people will make arguments for whether it's something you believe in or it's based on their race, whatever it is. But if we train a AI based on the real data, which may actually be biased data, would the AI then also be racist? Would the AI treat certain people better than other people based on the demographic or something like that? And they hadn't drawn any real conclusions, but it was interesting. And it's kind of along the same lines of what you're saying. It's, and I think it was in this class last week, I mentioned there was this movie that was about, had the perfect AI and then turned it on. The very first thing it did is kill all the people. So it was trying to save the world, and it decided the biggest plague against the world was humans.
Yeah, but Microsoft experienced the same thing. So they have introduced a bot. I don't know if you remember this code. They have introduced a Twitter bot. So that is a machine learning. So it will converse with other Twitter.
Yeah.
And it will learn by learning. So trolls on the internet about that. They have filled all the racist, political incorrect.
Oh, right.
So it was started repeating.
Right. Yeah, I remember that. So it started incorporating those into a speech pattern. Yeah.
And then they said like because like within the field it's mostly male dominant, and most of the people that are creating the technology that we're using as AIs are like males, white males, and Asian males. That are mostly like the people that are writing the programs. And then it's just like people are like some AI researchers like think that we should have like a committee that sets standards for them to follow when they create AIs, and that like AI shouldn't just be based on their point of view that causes the problems that we see today, because there's things that sometimes you didn't account for into your design that could cause harm and stuff like that to people. Or why didn't that like the program ask us why, but it doesn't know to ask us why? That like what should you do in this kind of situation if it comes like in this environment like you didn't account for? So there's like things like that I mean it's like really complex to understand, so like that's why
So next week you're going to look into more about kind of what people are looking into in AI as it relates to black box computing when things go in, and then you get a result that comes out, and you don't necessarily have transparency related to that result or how it came to that result.
Yeah.
Okay. Yeah, no, I think that's going to be pretty interesting.
Have you seen the movie Bird?
Yeah. That's the one with like the new OS, right?
There's
like
the new OS, and it's like a girl.
Right. Then they end up taking over the world.
And then they figured out that they were the ones that was destroying that guy's life, so they had to get rid of it. I don't know. It kind of.
Yeah, I remember it. Yeah.
That was a weird movie, but it was kind of interesting.
Yeah. Okay.
Okay.
Whenever you're ready.
Cool. So the first paper that I looked at was Neuromorphic Computing with Multi-Memristive Synapses. And I will be perfectly honest, the majority of the papers that I read till I was cross-eyed and still barely understood them. So if you guys don't understand them, I apologize, but I don't really either. So this one focuses on building a computer system closer to how the brain functions. So they have current methods, but they aren't up to snuff. So they're looking on focusing on the efficiency and the energy consumption of these computers, because right now the ones that they lack the real-time processing capabilities and they aren't energy efficient. They are proposing a multi-memristive synaptic model demonstrating the implementation using a nanoscale PCM device. So for those of you who don't know what memristive is, because I didn't either, a memristor is a hypothetical nonlinear passive two-terminal electrical component relating electrical charge and magnetic flux linkage. So this PCM device is a phase change memory device. So what it does is there's a layer of phase change material between two metal electrodes, and they pulse currents through it, and the material melts or solidifies and does certain things. So they're looking to find this current that they can pass through it that is applied above a crystallization point, but it doesn't reach the melting point, and that's like the optimal area that they're looking into. So for this one, they're looking for an efficient representation of the synaptic weights within non-spiking neural networks and spiking neural networks, and that's kind of how they're basing the balance off of it to determine the best computer system possible. Definitely difficult to follow, way over my head. But they are working on a novel approach to getting this computer system that works closer to how the brain functions. My second paper is, don't let the title scare you, it's about epilepsy, and basically predicting when someone's going to have a seizure by using algorithms. So they had a crowdsourcing competition basically to get the input information for epilepsy, because you have to look at it over a long-term period of time, and the current research before that didn't have enough information. So they had like 200, they had a ton of people, but they had about 500 days that they followed for information, and each person had over 200 seizures that they measured the information regarding it. So then they take all this and they put it into a learning algorithm, and they have concluded that you can predict it. So they're, depending on how long you view these episodes, you can predict accurately when someone's going to have a seizure in enough time that that person can either get to a safe spot and handle it, or they can implement like a interrupting procedure that will basically use an electrode to counteract the seizure, and then they won't have it. So this paper didn't have a ton of the technical information. It was mainly focused on the health aspects of things, but creativity-wise, it is a good preventative health measure, especially for epileptics, because it's hard to live your life or even be hired anywhere if you have epilepsy. Yeah, they found that they can predict it. They still have to kind of work some stuff out and have more information, but they found that they from the previous models that they used, there are certain patients that it didn't work for just because their type of epilepsy. So for this one, it hits a wider range of patients, and they also found that certain algorithms worked better for certain people. So just like medication would, it's patient specific. So it's they didn't say if it was like a trial and error patient specific, or if they could figure out just by computing something which algorithm worked best for them.
That's interesting.
The next paper used network analysis to look at fossil data, to look at associations of paleo communities in extinctions and radiations. So it's like a whole new category of ecology called network paleoecology, and it studies the changes in the biosphere structure and function and everything, and then uses the network analysis and computational models to analyze it. It went into detail on some of it, and I didn't understand much of anything. But the picture there is the network output that they get. So each A and B are different marine life environments, basically. And then obviously each color is a different aspect of it, and then the numbers inside of it are like the proportion within that ecosystem of what it is. It's a relatively new concept. There's really nothing else out there like it. I was interested in it until I found that out, because then I can't do a lot of research on it. But it's supposed to help with conservation strategies, amongst other things. But it basically looks at the at different eras of fossils. So they have a ton listed, and then it looks at the ecosystem as things became extinct. So, you know, like dinosaurs became extinct, but then what happened with the ecosystem of the tiny little thing over here or the plant over here because the dinosaurs became extinct? So it's things like that, except they studied the marine life quality of it.
Mm-hmm. What kind of result were they trying to get from it? So were they looking at the impact that, for instance, you said the dinosaur extinction happened. Now this is the ecological impact it had. What conclusion were they trying to draw from that?
So they weren't looking for like a specific conclusion, like they weren't trying to prove something. They're kind of using the information to bridge the gaps between past and present networks of life. So they're trying to see patterns in it, and then they're using that to either like detect certain threats that might come up ecologically, and then look at like if you would continue losing certain species, how would that affect the ones that are left? So animals that aren't yet extinct, once they become extinct, how would that affect the ecology around them? Yeah. And then they're using that information to work on conservation for different aspects.
Yeah, interesting.
Deep reinforcement learning for de novo drug design. So this one uses artificial intelligence for the design of new drugs. Reinforcement learning and then deep reinforcement learning is used in this particular model. And it looks into the ideas of molecular docking, transcriptomics, reaction mechanism elucidation, and molecular energy prediction. So basically, it takes all the aspects of drugs that people might, like everyday people might not think of. So melting point of a drug, or hydrophobicity. So if something likes water, doesn't like water, and it can build these drugs on the basis of the receptor that they're meant to go to. So instead of having a drug and picking the qualities that you want first, it takes the receptor and molds it to what qualities will fit with the receptor. So it'll benefit pharmacologically. It could help with dosing. It could help with depending on where your medication goes. You know, you swallow a lot of your medication. So a lot of your medication that you take doesn't actually reach where it's supposed to reach because it has to go through all these things. So if they can pick this receptor-specific drug, it would not bind to other areas of your body and go more to where it needs to go. And then the release system, that's just their model that they're working with and moving forward with. And my last one was really hard for me to understand, but it was basically using network analysis for a GWAS summary, which is a genome-wide association study. So they created this software program, GSA SNP2. Where did I write that? The SNPs are single nucleotide polymorphism. So basically, it's a variation in your genetic code. So this computer program can take a certain value, the p-value from the SNP, and put it in this computer system and run it, and it can tell you different things about this variation. So the idea behind the GWAS is they just look at the genetic code and variants, and in humans, they're trying to find connections between the variations and diseases. So you can either predict from seeing a genetic code what diseases someone might get, or you can prevent it by knowing which genetic code markers are causing the problems. So this one's actually a C+ program, and that's the only part of the technological aspect that I understood. But otherwise, so they didn't go into much detail with the software program. They did provide the software program, but I was not brazen enough to look into that.
That's okay. I mean, this is actually kind of the perfect example. So if I use her slides as a good example, you read 5 papers. There's aspects of each of these papers you got something out of, but largely there were things A, you learned from them. B, you said, okay, I'm not interested enough in that to dive further. And then, C, you came away from it with probably, even just the areas that you kind of discussed just across these 5 papers are things that maybe you wouldn't just come up with on your own sitting in the park someday, right?
Oh.
You're sitting there and you're like, what? Look at these papers. Okay, I have this homework assignment I got to do. I got to find 5 papers. I mean, who would have ever even thought about looking at fossil stuff and ecology after that, and whether it leads to anything real or not? It's something that we've now considered and like, okay, well, that's maybe interesting. And that's kind of the whole purpose of this. We're reviewing the current state of research, and what's I think good in this group is we each kind of touched on different things. Instead of having everybody do like all the same topic, and that sometimes becomes the problem with everybody congregates on top of a single topic. But yeah, I mean, actually, I think these were kind of perfect papers for this type of thing, and it's good that you look at them and say, yeah, I don't know what the hell happened this meeting or something like that, because all of us would have been in the same boat. There are aspects, I mean, so, you were formerly in the pharmacy program, so you have a background in that type of stuff. So, several of your things were twisted more towards the drug side of things. So there were aspects of that you were more comfortable with, and then you had the technology thing of it, which you found interesting. Like, okay, well, how does this connect with this? But you were less comfortable with it, but there maybe hopefully made you think about some things that you didn't otherwise think about. I mean, actually, out of the whole thing, the thing that maybe I found most interesting had nothing to do with technology, just the idea of trying to get the drugs you take to be more directed to where you need them. I mean, I take all these pills every single day, and I mean, I'm assuming I have a fairly robust digestive tract and stuff like that. So who knows where all this medicine is going in my system, right? This kind of sounds like the future of medicine to me in some regard, that we're going to stop just swallowing this random pill and it's going to become at least more targeted. I don't know how, but maybe this is how. So I don't know. I found that pretty fascinating. So what are you focusing on for next week?
Shockingly, I want to look more into the the RL and deep RL artificial intelligence. I haven't decided if I'm going to focus on the emphasis on the drug research, hence the drugs or no drugs. I don't know yet, but but if that's kind of the direction that most of the papers go, then I'll go in that direction too.
Yeah. No, this was really good. This was exactly, if you want to use it as a model, this is exactly what I'm looking for. The rest of yours suck.
It's kind of like
They were all pretty good. But this was a very good model if I were to give it a demonstration on the first day. Plus, if you remember last time I kind of mentioned that what researchers try to do is they come up with these fancy schmancy names. Half these things we couldn't even pronounce, right? Fancy schmancy names for stuff that make them sound smarter. If any one of us read one of these papers, any of these papers, there's going to be maybe 30 or 40% of it that is going to make sense to us. And most of it's going to just be, and it doesn't mean that we're stupid. It just means that the background that those folks have is compatible with what they're writing about, where we don't have those backgrounds and we're trying to get just a peek. There's plenty of papers where like, okay, well, I'm never going to have that background, but I still find that interesting. And that's kind of the punchline for it.
But isn't like most of the research done by like multiple fields anyway? So that's why. Because even
there's probably a true
even within the field too, we specialize in an area too. Even we do research with someone within the field, we're also specializing in something else too within the field.
You're probably right that there's quite a bit of collaboration across interdisciplinary collaboration for these things, but you also, especially today, you have a whole lot of specialized research where somebody is so focused on a very, very, very specific thing that unless you are just big into that, most of their stuff is going to be beyond you, but that doesn't mean it's not interesting to think about, because if you read these 3 papers that maybe you only absorb 30% from, they might give you an idea to look into something else. That maybe is completely unrelated to them, but it might have just sparked something, and that's kind of one of the advantages of reading other people's research. I mean, and the whole reason we want to read these weird-looking papers is because they are hard to get through.
Yeah.
It's hard to just sit there and read one of these papers because they're boring, right? Until you stumble upon a paper that says enough interesting stuff to you, like that's, it's almost like reading a book. You have your favorite authors or something like that, and usually you'll like your favorite author's books because they kind of are speaking your language. Yeah. But if somebody says, "Oh, you're gonna read this book, it's the greatest book ever," and you just can't get past page 20, because the thing is just putting you to sleep, it's like the best tool ever for going to sleep at night. Have you ever found one of those books? I found shows that are like that. It probably took me 12 or 15 tries to finally get through the second episode of the show Lost. But then I got addicted to it. Finally, I got past the second episode. Once you get to episode 6, then you're hooked. But it's kind of that type of thing. So you're not looking, as you go through these, you're not looking for complete understanding. In fact, if you have complete understanding, you're either deluding yourself,
the thing is,
or you're very, very, very well rounded. one of the two.
There's 2 songs that I watched on Netflix. First one was called something that I don't remember the name. About Bible too.
Okay.
The second show was the Zombie Girl.
Okay.
I thought it boring. I watched it through episode 1 to episode 2.
Yeah.
Like the girl had to eat the brain to survive.
Yeah. Is that iZombie?
Yeah, iZombie.
Yeah. It's always the most embarrassing when you have a show that's like you're not supposed to be hooked in the time, and you're like almost ashamed to tell other people you watch this. Like I got hooked on Buffy the Vampire Slayer. If you go and look at that, the acting in that show is absolutely terrible. Recently. Yeah, I guess that does make a difference. Well, actually, hold on, is that worse?
It may be worse recently.
Yeah, I think it is worse. I got hooked on that. But yeah, so in any case, so for next week, we are picking our topic that we're going to look more into. We're going to write a paper about that, and then we're going to come and give a pretty similar presentation about what we learned.
The paper, do you want it to be like a research style, like?
I don't necessarily care. I'd rather I would say write the paper in the style that makes the most sense for how you want to get your point across. I'm not going to be looking at it for.
So don't be confusing like how we were reading these papers.
Well, you can be. I mean, if you don't really understand what you're doing and you want to take the track of saying, okay, well, I'm going to basically hide a little that I figured out inside of a whole bunch of fluff, that's a skill.
Is that what a lot of people do in the research?
You're reading the papers, right? You're reading the papers and you're seeing it. So I don't necessarily care. I guess I would just assume that you write a paper not following a specific format like this. Appreciate that if you were going to go and publish some stuff, this is what the format would look like. But writing this paper in a way that's more comfortable to you, that way you can focus on learning about this subject as opposed to coming up with this weird format for having the 2 columns and crap like that. So just write the paper. Don't worry about following a certain style or anything like that. This is all about advancing our own personal knowledge. Kind of make sense?
Yeah.
All right, so questions about what's happening for next week? Not too bad. It went quicker than I thought, but it is what it is. All right, well then I will see everybody next week. And hopefully the golf course is open tomorrow. All the rain is just.
It's been awful. I was driving by the river club to go launch the boat.
Oh, you can't even go down there.
Yeah, the road's closed.
Yeah. Yeah. So and even like Monday, the course. Mondays a lot of times the course is open,
for